Hello. Yeah, I'm going to be talking about real-time customer analytics at Braze. I'll talk a little bit about what real-time means, what reporting functionality we offer, so what customer analytics means, and a little bit more about what Braze does and a basic example of the kind of orchestration loop that powers reporting. So I've been with Braze for about 5.5 years. I manage the reporting team, as John says. This is I think the most professional picture I could manage to find. So yeah, first, what is Braze? We'll go through that basic example. Lifecycle platform events mostly is going to be about the existing architecture we have using MongoDB, kind of what happens to an event as it flows through our system and how we query it, and then transforming analytics with ClickHouse. Spoilers. So Braze is a multi-channel customer engagement platform. This is probably the simplest example of the loop for reporting is that Braze customers can send a marketing campaign. They record end user actions, for example, email open, email click, and we enable real-time reporting on the data. Currently with MongoDB, currently with Snowflake, currently with ClickHouse, and then kind of repeats. Customers will be able to see these analytics, sends, delivery rates, conversion rates. Again, this is probably the most contrived example I could find, but this is how it works. In terms of scale, like John said, we have trillions of events, petabyte scale, which is big data to me at least, and then billions of messages sent per day. And so that is just message sends, for example. It doesn't include all the events that are coming in. That's custom events, user profile updates, purchase data, so revenue events coming in. That's more on the order of like 1 billion plus per hour or so. So the current architecture we have right now, and Braze has grown with, is that an event comes in all the way on the left here. It flows through our event processors. And so the event processors apply all sorts of transformations, any sort of side effects we want for data coming in to apply to other systems can happen there, be dispatched there. And again, these are events through API calls, through SDKs, through different integrations our customers have set up. Through events that our email service providers send us, so anything you can imagine. And right now, one of two things will happen when an event is sent out of the event processors. One path is that it gets sent to Kafka, and I'm simplifying a bit here, but it goes to Kafka and then it goes to Snowflake as our raw event store. We use that for a few things. We use it for debugging. We have a data sharing feature that customers can just get full access to some of that data. We have some reporting that requires access to the raw events, and that's things like attribution reporting or funnel reporting, where we need a necessarily sequenced chain of events that the user defines after the events come in. So that's why we're using Snowflake. That's one path. The other path is to MongoDB. So we have 1 billion plus events coming in an hour. We can't just write all of it to MongoDB as every single event comes in, because that would just destroy it. So we have a MongoDB writer, and in that is kind of this flusher class where we store all of the events in Redis for a short amount of time. We'll say, okay, we're getting all of these send events, custom events, revenue events that we want to associate with certain campaigns or message IDs or whatever. Periodically, we'll flush that out to MongoDB to reduce pressure. That's the second path. And there's a lot that can go wrong in either system, so we'll talk about like why that can be a problem and why we needed to fix it. Delivery semantics is an interesting one. With Kafka, you can define, for example, exactly once delivery or at least once delivery. With our bespoke MongoDB flusher class, we have to try to re-implement like any sort of delivery semantics if we want them to match up with Kafka, which is another system to maintain. That leads to issues with data integrity across reports. So it happens that you can run a report or on the Snowflake data that will reflect email sends in some way, and then you can run a report against the Mongo data in campaign analytics, for example, where you see all of the marketing campaign specific stats that will also show you email sends. So if the numbers are different across either source, customers do notice and they do contact us, and it does harm customer trust in the long run. infrastructure cost, management, maintenance. So there's a very real monetary and human cost to maintaining these two systems, especially when there are issues across them. So as much as possible, we wanted to kind of simplify the pipeline to source from one single place. Our options here, we could use Mongo for everything. That's kind of a non-starter because of the more complex analysis that I mentioned earlier, where we need access to the raw events. Unless we want to store them in Mongo, that's not really possible, unless we want to spend a fortune and wait 20 years for reports to run. Use Snowflake for everything. Also possible, there are a few different ways you could do that. Maybe there are some Snowflake experts here, but every option we kind of evaluated in Snowflake for this had some major caveat to it. So that leaves us with maybe a third option. So we, after evaluating a few things, ended up going with ClickHouse. I'll talk about that in a second, but this reflects the desired data pipeline. So if you remember the graph before, there were two splits from event processor, one going to MongoDB, one going to Snowflake. We want everything sourcing from Kafka. So as long as the Kafka system is stable and up and we have proper observability and everything, and we know that it's working broadly, then we can assume that data integrity across Snowflake and the other system will be good. There will be 100% data parity. A lot of our problems go away. So what to put there? The requirements we had for this, we wanted it to be a managed service. We've done some self-hosted database work at Braze. It turns out to be a lot of work and not something that we just want to support long-term. Decent local dev tooling was like the other side of that. I don't know how many Snowflake users are here, but if you have ideas on how to make your local Snowflake development experience better, please share them with me because I am out of ideas. Large-scale data ingestion, I think from Kafka is the more important bit there. Again, we want everything to source from a single place. Fast aggregations, I'll share some Mongo results later. I think the bar is pretty low when you're doing large-scale data aggregations with Mongo. High read volume, again, this is relative. High read volume to me, and then not outrageously expensive. So some of the Snowflake options were cost prohibitive. Some of the other platforms that we looked at were also cost prohibitive, or they didn't meet some other things here, like maybe they didn't scale horizontally. I'm not going to name names, but lastly, real time, that's in quotes because it's also relative. What that means for Braze is that customers can practically like create and manage campaigns without meaningful delay and like getting the results and understanding whether something is working. So if you go into the Braze platform and create a campaign and send it, you should be able to refresh the page and within a few seconds see that send reflected. It's a useful tool for customers understanding whether the system is working as intended. For more complex integrations, they can't wait 30 minutes to understand if something is broken. So we went with, ClickHouse. They provide a Kafka connector, which made this quite easy. So currently events will flow from Kafka, go to Snowflake, go to ClickHouse. We'll be able to run reports without any kind of discrepancy. And it works for us. How we do this, this pattern is probably familiar to a lot of people here. It's the classic like raw event table, materialized view, aggregate table pattern. So email sends I've been talking about, this is the example. The events coming from Kafka are just stored kind of as is in the raw event table. The materialized view, I don't know if people can see it, but it's just an hourly roll-up of messaging stats, and then we store those in the aggregate table. We do let companies and customers define custom time zones. So being able to transform, or I guess cast this data from UTC into a different time zone and being able to let them change that kind of on the fly is very nice to have. And it's great that we can do these aggregations natively in ClickHouse instead of having to like run them, get the data out, transform the time zone, or cast the time zones into something else, and then send it back to the customer, because that can take quite a while on very large data sets. For the specific table engines, we worked with ClickHouse kind of on the schema here. If you see any room for optimization, again, talk to me afterwards. This is my plug for ClickHouse to build a first-party Ruby driver. I see a few floating around. I think GitLab just built their own. We had something in our existing code base. just a generic network driver that already supported connection pulling. So this wasn't too terrible for us, but if this existed, we would definitely use it. Here is the before picture for a report. In this example, it's a feature that lets users compare multiple campaigns against each other to stack, conversion rates, bounce rates, et cetera, all against each other, again, or in a certain time range. I don't remember exactly for how long this is. It might be a year of data for 10 to 15 campaigns. And you can see a lot of the time from this span, we're using Datadog for this, is spent in Mongo, just running a bunch of different aggregations. And the system we needed to build for this to make it work in Mongo takes all of the data and kind of map reduces it and parallelizes the work to do some reads and then sum it all up later. So yeah, we have this framework right now to just dispatch all of these different jobs, get data for a certain campaign, sum it all up at the end. And this is because if we tried to do it in a single job using the Mongo aggregation framework, it would take 10 minutes for something that customers expect to have access to in 10 seconds. So this means we need to do a lot of Mongo lookups. That's reflected here in these spans. A lot of it is just simply database access, kind of waiting for data to transfer across the wire. A lot of it is inefficiencies in the aggregation pipeline. A lot of it is that time zone casting I was talking about. All of that takes time. Recreating this query in ClickHouse once we have the data in. This is the exact same thing. It's the same campaigns. It's the same metrics, the same time range. You can see up there, it's very tiny, but it's 0.65 seconds compared to the original, like 8.03 seconds. So it's a lot faster than Mongo. A lot of the sort of inefficient aggregation logic that was happening in Mongo and just outside in that MapReduce framework is now just happening natively in the query. The data is consistent with Snowflake. We have to do less work. It's faster. It's just way, way better for us. So I guess if there needs to be a thumbnail for the meetup, you can just use this because it's like 10x plus faster. So now we want to continue expanding ClickHouse usage at Braze. We have an existing observability use case that's live for customers. We have an API usage dashboard where all these events are coming in from Elasticsearch. We're showing customers a product that just shows them API usage natively in the Braze dashboard. And it's much cheaper and faster than just giving them access to Elasticsearch or trying to build something on top of Elasticsearch. We have a bunch of legacy metrics that we want to migrate. I mentioned email sends as one example. We have well over 100. So some of those we still need to get into ClickHouse. And we have other more complex use cases that I see other companies have implemented successfully. So we want to explore user segmentation, attribution, more complex queries, anything basically that we're doing in Snowflake now that we can do cheaper or faster in ClickHouse, we do want to do that way. So that's pretty much it. I don't know if anybody has any questions about any of that, but I should have added a fin slide. That's it. Thank you. Yeah, go ahead.
Okay, so basically, I was asking if you mentioned that you had a secret sauce, and I was wondering if this secret sauce was, I don't want to exploit your proprietary knowledge and what you do from a proprietary perspective. On the other hand, it sounds very close to what McDonald's and Burger King tell us about their secret sauces. Can you tell us more about what's in your secret sauces?
Yeah, so which aspect of this in particular, I guess, can I elaborate on?
You just mentioned it as part of what they.
I guess stop me when I hit the relevant slide.
I don't believe it's in a written slide, but I believe it was in your commentary.
Yeah, I can't think of anything. Yeah, if you have a specific question about like a part of our architecture, I can share. But this is, I think, not too controversial. The only thing I really glossed over, I think, was the layers here. So like what happens with the data from Kafka to Snowflake and from MongoDB, from that Flusher class to MongoDB. So I don't know if you had questions about that or something else.
I don't remember the exact context in which you said that, but I remember you saying it, and just don't.
Okay.
It's exactly meaning.
Yeah, let me know if you remember any of the context around it. I would be happy to share. I don't remember saying it. Maybe ClickHouse is the... Yeah, it's open source. It's just good. ClickHouse is just good sauce. You can quote me on that. Yeah, we have another one right here, and then we can migrate to the east side.
Yeah, curious about the aggregation. Do you do pre-aggregation, or is it aggregation at ClickHouse side?
Do we do pre-aggregation or aggregating? So the Mongo layer right now, we like pre-aggregate the data. That is, we just have sums sitting in MongoDB in these big hashes, and we do that because we know what data we want to aggregate ahead of time. For something like email sends, we know we want to report on that. So we can define that in the code easily. For ClickHouse, the aggregations happen as part of this flow here. So what the materialized view will do is kind of act as an insert trigger for the aggregate table. So the raw event comes in. As soon as the raw event comes in, kind of sees the materialized view, and data is routed accordingly to the aggregate table. I'm sorry if my description of that offends more knowledgeable ClickHouse people, but that's the gist. So the aggregations are happening in real time as the data arrives at ClickHouse.
Okay, I see. So you materialize the aggregation so that it's pre-computed at a daily basis?
It's like per event. Like as soon as a single event comes in, it comes in batches technically through Kafka, but as soon as these events land in ClickHouse, they are moved into the aggregate table. So there's no periodic aggregation in that sense.
Okay.
That's also true with Mongo. More or less, our aggregation window is just very small, on the order of like 1 or 2 seconds. I think we had some hands over here. Also, sorry for my mic control. I'm a musician, and so if I'm not like screaming, I have trouble regulating the... Okay.
I'm just curious how you decided not to do this in Snowflake. Like you talked about this being much faster than Mongo, but presumably Snowflake also great at aggregates. Like what was the trade-off?
Yeah, I wish I had the design doc handy. There are, like I said, a few ways of doing this in Snowflake. You can do materialized views there. We could have a job that does periodic aggregations just by going and querying all this data and putting it into some other source. We looked into, I think, dynamic tables. When we did, I think there was a restriction on dynamic table size, which made this difficult. Maybe that's been lifted since. But pretty much every option had either a performance concern or like a data freshness concern, because we also have to support late arriving events. And if something comes in like much later, we're not going to get it. If we have kind of a moving window of like last 30 days, we need to be able to support events coming in today for something that happened 31 days ago. So that was another challenge that's kind of mitigated by this, because as soon as an event comes in, it just goes wherever it needs to. Also, cost was a concern. We have enough queries where we would need like a read warehouse operating 24/7, maybe more than one read warehouse just running 24/7 for the sole purpose of users being able to query the data. So having it all in a managed service, or in one single ClickHouse instance rather, is easier for us to control. And again, the data gets there sooner. We don't have any of the freshness concerns. I think that was mostly it.
My question is more actually around the resources. You switched to the managed service, but I'm curious if you can do like a comparison in terms of the like utilization of resources between the Mongo cluster and whatever you have now in managed, like in terms of CPUs, RAM.
I don't have the Mongo data. Maybe John would if he's still here. Yeah, I don't know. I don't know how it stacks up against Mongo, but I do think that reporting in Mongoland is like a smaller percentage of total utilization. So this is a problem that we can like look at more narrowly compared to like message sending, for example, which has its own class of kind of Mongo concerns.
Got it.
We have one more, I think, over here.
About the trade-offs, did you consider trade-offs between doing the aggregation at the event stream level, like using Apache Flink, versus what you're doing here in the aggregation at the database level?
Yeah, I don't know if we looked into Flink in particular, but we looked at maybe K-streams, doing it that way. We had other teams build features using that, and their advice was don't, just because it was more difficult to implement, it was trickier to maintain. So we more or less took their word for it. I don't know if anybody else is going to come up here and talk about Flink. I hope so. I think that's one more. Do we have time for one more?
Hello. Hi. How did you guys, if you encountered this problem, handle like data accuracy in like moving off of Mongo to ClickHouse? Did you have to use any tactics to ensure like your reporting had parity with like the previous implementation?
Yeah. So one of the things we were trying to solve was data integrity across different sources and reporting accuracy. So it's good for us if the ClickHouse data does not match Mongo, because we consider the Mongo data not super accurate. So the source of truth, I would say, is Snowflake, because all of those events are coming from Kafka. And again, like it's easier for us to understand when there are errors with Kafka compared to the Redis flushing system into Mongo. It's easier for us to figure out like exactly what data we lost if we did, or what events were double written, because we can go into Snowflake and look at the IDs and deduplicate them. So that's a nice escape hatch to have, is like if we notice any discrepancies, we can just backfill from Snowflake. If we need to fill like historical data after we implement ClickHouse for a certain metric, we can backfill from Snowflake, and all of the data will match up. And we can also confirm that against our like other internal logs or our like Elasticsearch cluster. So yeah, difference in the difference in the data with Mongo is a feature.
Well, I have a follow-up. Since you mentioned backfilling, how often do you guys find yourself having to do backfilling, and is it easy for you? Do you have like a robust system for it?
It can always be more robust. We haven't had any incidents now where it's like this data is wrong, we need to backfill it from Snowflake. So we're still kind of maintaining it as like one time whenever we stand up a connector to send the events to ClickHouse, and then maybe later if something happens, like the ClickHouse connector falls over, or like our DLQ setup doesn't work, something like that, then we'll do it. But never really, to answer your question.
Another round of applause for
Thank you.
Caleb.